Hi Vitalis. So today we want to solve the problem on the hurdle race. Player plays a game in which the character competes in a hurdle race. Hurdles are of varying heights, and the characters have a maximum height they can jump. There's a magic potion they can take that will increase their maximum jump height by 1 unit for each dose. How many doses of the potion must the character take to be able to jump all of the hurdles? If the character can already clear all of the hurdles, return 0. Okay. I think the way we have to understand this problem is okay, so we have a height, and then this is an array, and over here it says the character can jump 1 unit high initially and must take 3 minus 1, which gives us 2 doses of potion to be able to jump all of the hurdles. So what this means is that this is what K stands for, how high the character can jump, and we want to see if this character will be able to go through or jump all of the hurdles that are given in the array. So if we take the maximum number or the maximum height in the array, so over here the maximum is 3, it means that we subtract 3 from 1 and then we get 2. It means that he has to take 2 doses so that he can jump the very third one. So that is the first example, where we have a number of inputs, that is 5. These are the various heights, and this is the natural, 4 is the natural height the character can jump. So if we want to know the number of doses this character has to take, it means we need to subtract 6, that is the maximum number here, minus the height this character can jump, that is 4, and that gives us 2 doses, and we return that answer. So that is, I think, the explanation for the problem. Now the way I'm thinking we have to solve this problem, I'll first write here a pseudocode stating maybe the things we have to do to solve the problem. So first one is that we need to find the max number in the height array, and then after we find the maximum number, then what we can also do is that we find the result of that number. So we just do a subtraction. So subtract subtract normal height, or I think this has to be natural height jump from max number. Okay, so when we subtract, it will give us the number of doses, so we can return this one, or else we return 0. So I think this is the way I want to go about solving the problem. So first of all, we need to find our maximum number. So I'll say let max number give max number. Now to find the max number, this height here is an array, so we know we have a method called math.max, but so we do math.max, but we also need to use apply, because math.max does not work on an array. When we pass in an array to math.max, what we get is we can get, I think, null or undefined, I think something like that. So we have to do math.max.apply, because apply will allow us to pass an array to the math.max function. So math.max.apply, then now apply takes 2 arguments. It takes a first argument, so over here we see it takes this argument and then the argument array. But this one,
Okay.
because we are not dealing with any state, this is just static. What we are doing here is static, so we don't need any this dots, we don't have anything like that, so we can just
Yeah.
make this null, and then we can pass in the array that we need to find the maximum number from. So this actually gives
Okay.
us the maximum number, and then what we can do is to find, let's say, let results give us so the results will give us the maximum number that we found minus k. The k is the natural the height, the natural height the character can make. Okay, so once
Yeah.
we have the result, we can say that
Yeah.
if so an if statement, if
Positive.
result, so if result is greater than 0, okay,
Yeah.
then we return results.
Okay.
Then we can just say else return 0, because if the result is less than or equal to 0, we can also do an if statement here, but I think it's shorter. If we just say else, it should just return 0.
Yeah, we can also eliminate the else. We just have the return 0.
Okay, yes.
Because
It also makes it shorter. Okay, but first let's run this and see if this
yeah.
works. Okay, so okay, we passed, right?
Yeah.
Okay.